welcome to today's lesson. So right now, guys, we're going to be focusing on quadratic equations. So before anything, we're going to look at our leading question, which is going to be the question that's going to remain at the back of our heads as we're going through this lesson together. Also, we look at a mapping of what is equation, or what is an equation rather, and what are the things that are involved when talking about an algebraic equation. But for now, let's just have a look at our question together. Now, the very first question that I want to ask you is, have you ever ridden a quad bike, right? Why am I asking this? It's because you'd see that a quad bike normally has 4 wheels. But now, what does the prefix quad usually mean? Because if you look at what you're talking about, a quadratic equation and a quad, because remember, this prefix here normally means 4 when you're talking about the prefixes that we use in mathematics. But now, quadratic equation has nothing to do with 4. So what exactly is the link between the two? That's one thing that I want you to be thinking about. It's quite an interesting thought that I had when I was looking at this. Now, remember our algebraic equations, we have different types of them. We've looked at our linear equations so far. For now, we're going to look at the quadratic ones, and then the rest of the others we'll then maybe look at a later stage. To solve quadratic equations, the main operation that we do, or the main process, is factorizing, and you know the different types of factorizing that we looked at previously. The keywords for this lesson will be, firstly, we'll look at what is an equation on its own, and then how does an equation become quadratic. And in a quadratic equation will be things that we talk about, such as a coefficient. What does that mean? We're going to be looking at that. And then lastly, it will be what exactly does it mean when we say we are factorizing. Remember, an equation will be a mathematical statement consisting of an equal symbol between 2 algebraic expressions. Now remember, an expression will be, if I say to you, an unknown number plus 5, what is it in mathematical terms? So it means you will say x plus 5. But if I say now an unknown number plus 5 has to be equal to 13, then you will say x plus 5 equal to 13. The equal sign is what distinguishes between an expression and an equation. And the other interesting thing about the equal sign is it really means that the 2 expressions that we are talking about are equal to each other, meaning they have the same value, which is my next point that I'm going to talk about just now. So the equal symbol normally means that the 2 algebraic expressions have the same value. So with the example that I've been talking about, maybe x plus 5 equal to 13, right? Whatever this unknown is must be such that the left-hand side expression is equal to the right-hand side expression. That's what the equal symbol really means for this particular equation. An example of an equation will be, if I have 5x plus 9 equal to 24, we label this in the following way. The 5 in front of the x is normally called the coefficient, and the x itself is called a variable. So we don't really call them alphabets in mathematics, we call them variables. Then the equal symbol will be what tells us that one side has the same value as the other side. Lastly, we have a constant. Now the constant is not only the 24, even this 9 here is a constant, just that I was labeling the 24 alone. So any number that does not have a variable next to it, we consider it as a constant. Now, a quadratic equation in specific now, so for an equation to be quadratic, we say it is quadratic because it has a second degree. Second degree means at least one term needs to be squared. And the standard form for this is normally given as ax squared plus bx plus c equal to 0. I need that equal to 0 there because it talks about one side being equal to another side. And then the value of A, B, and C are not variables. No, they are just constants. So they are actual real values. So A can be 1, A can be 2, it doesn't really matter. We don't consider them as the variable. The only main variable here is our x and our x there. The quadratic equation, the standard form that we are seeing, means that at all times, one side of the equation has to be equal to 0 for it to be considered a quadratic equation, but only in standard form. This does not mean if I give you x squared is equals to 25, this is not a quadratic equation. It is, but if you want to write this as standard form, then it becomes x squared minus 25 equal to 0. This 0 here is important because that's what tells us how do we then start solving. The other last point now about a quadratic equation is that it has at most, remember when I say at most, it means the maximum number of solutions has to be 2, and it has to be 2 real solutions and not non-real solutions. Remember, non-real has to do with when we're talking about a square root of a negative number, that is a non-real number. But with a quadratic equation, the maximum number of solutions will always be 2, provided that it is in standard form. So that squared there that I said was a second degree is what tells us that you must have 2 solutions at all times. But that's the maximum, meaning minimum can be 1 solution that is the same. So it can be x is equals to 2, x is equals to 2. It's just 1 solution, but 2 values in a way, but because it's 2, we'll treat it as 1 solution. Guys, for now, I want us to take a quick ad break. When I come back, we'll then look at more of this quadratic equation and throw in some examples there for us to have a look at together. I'll be back just now. Hi guys, welcome back from the ad break. We are still looking at the concept of quadratic equations. Now we're going to look at how do we then solve quadratic equations, right? What are the main things that you need to look forward to? What are the principles? I'm going to give you one principle and then tell you about factorization just so that we can refresh our memory as to how do you then factorize when given a quadratic equation. So let's have a look at it. Now, firstly, we have what you call a quadratic equation, right? To solve that, you always need to make sure that you first rewrite it in standard form. That's your very first go-to place. You do not do anything unless it is in standard form. Number 2, you then factorize. You know the types of factorizing. It's not only about 2 brackets. It can also be a common fact. And then from there, you apply the 0 factor law, which I'm going to show you just now. Lastly, I want you to always check your solutions, guys. Why is this important? It's because you come out of the exam knowing exactly that I got this right, I got this incorrect, and you might have time to fix the ones that you got incorrect. Now, the principle of solving, which is actually called the 0 factor law, says that if A multiplied by B is equal to 0, then either the A will be equal to 0 or the B will be equal to 0. What does this really mean? Let's take, for example, the A is the one that is 0. It means that I will have 0 multiplied by B, which is definitely going to give me 0. So you can see it gives me the right-hand side there. Now let's take if B is the one that is 0, it will be A multiplied by 0 equal to 0. Because A multiplied by 0 is definitely 0. So that's why both of them will then be solutions. But it is an or situation, not and. Because if you say and, then it's like you're saying they are intersecting to each other. And they are not. It can either be this one or that one. That's why we use the or word. Now, the example of solving quadratic equations using this principle that we just spoke about. If I was to write this in the form of my A and B, this will be the A, and the whole bracket will be the B, right? So remember my law said, if a multiplied by b equal to 0, then a will be equal to 0, or my b will be equal to 0. So that's where we're taking this from. Meaning, this will be x is equal to 0, that's one solution, or the x plus 3 will be equal to 0. But at all times, because we're trying to solve for x, it means x must be left on its own, on one side, and then an equal sign to show that we have found the answer for x. So this becomes then x is equals to, so you subtract 3 here, you subtract 3 there. Why? Because it's the additive inverse, right? Making this to be equal to a negative 3. So my two solutions here will be x is equal to 0 or x is equal to negative 3. Remember, what did I say? Because this is a quadratic equation, it definitely needs to have at most two solutions. Maybe someone might ask, how is this a quadratic equation? Because there is no squared. If I was to multiply out this x inside the bracket, this will give me x squared plus 3x equal to 0. You see, so my squared is definitely there, just that this was already simplified for us. Another example now is when I have two brackets, right? You know, when you have to expand this, it will definitely give us a quadratic equation. Maybe let me quickly show you that before we can even solve it. But you don't need to do what I'm showing you now. This is just for me to show you the quadraticness of this particular equation that I've given you. So x multiplied by x, you know, will be x squared. X multiplied by 2 will be negative 2x. And then 3 multiplied by x will be 3x. And then lastly, 3 multiplied by negative 2 will be negative 6 equal to 0. So automatically you can see my squared is there. And that's what I said was the definition of a quadratic equation. Now, to solve this, remember this is my a, that is my b, it is equal to 0, and it's a multiply between the two, right? And we know according to this, it means a will be equal to 0, or b will be equal to 0. That's the principle we are using. So, it will be x plus 3 equal to 0, or x minus 2 equal to 0. If I solve for x, I will get x is equal to negative 3, or x is equals to a positive 2. Now, remember my last point when I spoke about how to solve this. I said check your answers, right? Let's quickly go back to the previous one. If I check my solution here, I said the first answer is 0. As soon as I have 0 and I have a multiply by something, automatically it just makes it 0, right? So this solution is correct. Let's test for the negative 3 there. It will be minus 3 inside the bracket, minus 3 again, plus 3. And then minus 3 plus 3 is 0, multiplied by negative 3 will be equal to 0. So the left-hand side is always equal to the right-hand side for it to be correct. With the one that we just did as well now, if I substitute my two values there, firstly, if I substitute negative 3, it becomes minus 3 plus 3, which is 0. 0 multiplied by anything gives us 0. With the 2, if I substitute 2 here minus 2, it will give me 0. 0 multiplied by anything is always going to be 0. So both my solutions are correct. Now remember, to solve a quadratic equation by factorization, the first thing you always need to do, guys, I will keep on emphasizing this, is to make sure that your quadratic equation is in standard form and one side is equal to 0 at all times. And then the very first thing to do after doing that is to test for a common fact, right? But because here we have a 0, it becomes a bit easier for us to deal with the common fact, right? It's actually the highest common fact. meaning you will divide every term by that common factor that you got, and the right hand side, because it's 0, remember anything 0 divided by anything, will always be 0. I just cannot divide by 0, but I can divide 0 by anything, and the answer will forever be 0. So that's where the nice thing comes in here when we're dealing with an equation as opposed to an expression. An expression, if you take out a common factor, you will remain with your common factor until you get to your final answer. But with an equation, as soon as you take out a common factor, you can just divide both sides by the common factor, and it will then go away because of the 0 on the right-hand side. So please remember that as we're going through these questions. Now, when you look at the last sign and the factors of the constant, right? The factors of the constant will be the last term. Firstly, with the signs, if the sign of the last term is positive, it means my two brackets will either be positive and positive, or it will be negative and negative. What determines whether it's positive and positive or negative and negative is the middle term. So if I have ax squared plus bx plus c, I'm just writing it in standard form. The middle term here is a positive, right? And my last term is a positive. It means my solution will have two brackets that are positive. But if it now becomes ax squared minus bx plus c, the last term is still positive, but now the middle term is the one that's now negative. Then it means my two brackets will be negative and negative. So that's what determines whether it's a plus and a plus or a minus and a minus. But definitely, as soon as the last term becomes a negative, then your two brackets will be different, right? It will be plus and a minus. And then the most important thing here will be to always look at the middle term. So I will say to you, just for an additional note for you, the bigger factor, right? The bigger factor in the bracket, I will say factor, gets the sign of the middle term. The sign of the middle term of, I'll say m term. Right, so the bigger factor always gets the sign of the middle term. So let me make a quick example. If I have x squared minus 2x minus 3, right? And I want to factorize this. I know it's going to be x and x. My factors will be 3 and 1 for the last term. And then because the last term is a negative, it means I must have a plus and a minus, right? But now, where does the plus go? Where does the minus go? That's where you consider my additional point that I just gave you now. The bigger factor will get the sign of the middle term. So my bigger factor here is 3. It means that's the one that must be minus, and then the 1 will then be a plus. So that's how you really look at how to then place the two signs. So the typical example of solving for x using factorization, you look at it. Is it in standard form? Yes. Is there a common factor? No. Then you go straight to factorization. The last term is a minus. It means my two brackets will then be a plus and a minus equal to 0 there. So it means this will be x, and then I will have 3 and 1 minus plus, and then my two solutions will be x minus 3 equal to 0, or x plus 1 equal to 0, then my x will be minus 1, or my x will be equal to a positive 3. And those will be my two solutions for this particular question. Another example where now the coefficient of the leading term is not 1, you still do the very same thing, factorize, right? I know this at times is not easy to do the factorization. It becomes 2x and x. Now I need to place my 3 strategically. It must be such that after foiling out this thing, I get 1 as the middle term. So it means my 3 will be there and my 1 will be there. And remember I said the bigger factor always gets a negative. It will be negative, it will be plus, because my middle term is a negative. Then it becomes 2x is equals to 3, or it becomes x is equals to minus 1. I hope now you are following how we do this. And then my x will be 3 over 2 because I need to divide both sides by 2. And then or my x is equals to minus 1. And those will be my two solutions. And then remember to test your solutions right after working it out. And then another example as well will be minus 5x squared plus 7x minus 2. One of the main things that I will always say to you is after writing it in standard form, just make sure that the leading term, meaning the term that has x squared, is always positive. It makes it easier for you to factorize, right? It is possible to factorize it like this, but it's easier to factorize it if it's a negative. So it's a positive, I mean. So just make sure that it's always a positive by dividing everything by positive, which will then give me 5x squared minus 7x plus 2 equal to 0. And then you open your two brackets. This will be 5x there, and it will be x. Then it will be 2 here, it will be 1. Remember, the last term is a plus. It means it must either be plus, plus, or minus, minus. Because of the middle term, it therefore becomes minus and minus equal to 0. And I will have 5x is equals to 2. And then my x will be equals to 2 over 5. Or my x will be equals to 1. Then you can quickly go back to all of them. So I'm just going to go to all of them to show you how you then test this, right? You substitute this on the original equation I had given you, not the one that you factorize, because at times you might miss a number when you are factorizing and you are testing it with an incorrect thing, then it will definitely be incorrect. If I substitute my minus 1 there, it will be negative 1 squared minus 2 into negative 1 minus 3. The negative 1 squared, you know, is 1. This will be plus 2 minus 3. And this is definitely equal to 0. And the right-hand side is 0. So the negative 1 is correct. Then with the 3, it becomes 9 here when I substitute it, minus 6 minus 3, which is also equal to 0. To test this one quickly as well, if I substitute my minus 1, it will be 2 plus 1, which is 3, then minus 3 is 0. And then with the 3 over 2, it will be 9 over 4. You times it by the 2 here, it gives us 9 over 2. And then 9 over 2 minus 3 over 2 is definitely going to be 6 over 2, which is 3. Then it gives us 0. So that's how you then test this one. Then the last example where you need to test, substitute your 1. Definitely it will be minus 5 plus 7, which is 2. Minus 2 is 0. You substitute this one, you will see, and press your calculator if you are not sure with your mental maths, and it will definitely give you 0 is equals to 0. Therefore, your two solutions will then be correct. Okay guys, that's it from me. I hope you are having so much fun, but for now I want us to take a quick ad break, and when I come back we'll then look at some more quadratic equations together. So stay tuned. Hi guys, welcome back from the ad break. We are still looking at quadratic equations, right? But now we're going to look at other types of factorizing. Remember, the very first type we looked at was the one of opening two brackets. Now we're going to look at other types of factorizing, which is mainly the common factor and the difference of two squares, and try to see then how do we treat a equation that has that kind of a situation where you need to take out a common factor or factorize based on the difference of two squares principles. But let's have a look at a recap quickly before we can go anywhere. Now remember that to solve a quadratic equation, I still say you need to make sure you rewrite it in standard form. Firstly, you factorize after that with any type of factorization that is there. you apply the zero factor law, which I'm sure by now you are familiar with, and then lastly, you check your solutions at all times. I promise you, if you do check your solutions, you will thank yourself later at the end of every test that you have. Now, the different types of factorizing, the very first one, remember, is the common factor one, and the difference of two squares, and then a trinomial to two binomials. That's the one that we've already looked at, right? But the very most common one is actually the common factor, right? That's like me saying common a lot of times. Anyways, so a common factor is when factors are members we can multiply together to get another number, right? That's what a factor is. But now for it to be common, it means that it is a factor that appears more than once in two or more terms. It doesn't necessarily just need to be two. It can be four, it can be five terms. As long as it is common in all of them, then you can take it out as a common factor. And then also one of the main rules about a common factor is after you take it out, you take each term and divide it by your common factor, which I will call CF. Another term, you divide it by your common factor. Another term, you divide it by the common factor. Like that with all the terms that you have, depending on how many terms you have. Let's actually see how this comes about. So here you can see my common factor will be m, which is actually the highest common factor, if we call it properly, is m for these two terms. So what do? I said you take each term and divide it by the common factor that we have. So my first term is m squared divided by m. My answer will just be m. Hence, that's the first term I write inside the bracket there. I take the second term divided by the common factor, which I will then get -3. That's what I have inside the bracket there. And then remember, you apply your factor law rule. M is equal to 0 or m is equals to a +3. Where does it come from? It comes from m minus 3 equal to 0. Then you know the 3 will go that side because we want only the m. Now, the other type of factorizing has to do with the difference of two squares. This is about a perfect square minus another perfect square, right? And at all times, guys, it must be minus. If it's a perfect square plus a perfect square, then you are not talking about a difference of two squares. So it must always be a minus, please. An example will be me having a squared minus b squared. A squared is a perfect square, b squared is a perfect square, and they are subtracting each other. Now, on the subject of a perfect square, guys, as soon as you have variables, I will then say a perfect square is a number that you will have two identical factors that you will multiply to get that number. Meaning, every variable that has an even number as an exponent is a perfect square. A to the exponent of 6 is a perfect square. Why? Let me show you. So, a to the power of 6, or exponent 6 rather, is the same as a to the exponent of 3 multiplied by a to the exponent of 3. Why? Because if I multiply these two, I will need to add the exponents, which will be 3 plus 3, and it will then give me 6. And I just defined a perfect square as what? As a term that you can have two identical factors such that when you multiply them, you get that term. So please understand that, because some people think your perfect square is only when it's squared, or when it's like 4, 16, 25. No, that's not the case. If it's a variable, as long as it has an even number, then it's a perfect square. And to factorize this, remember, you will have two identical brackets, only differing in signs. One will always be a plus and one will be a minus, but the factors must always be the same. So it will be a plus b, a minus b. And then my solution will be a equal to -b, or a equals to a +b. And those will be the two solutions that I have here. Now, let's just look at actual examples now where they want us to find x. So to factorize this, remember this is a perfect square minus another perfect square. So the two numbers that I need to multiply to get a 4 are 2 and 2. The two factors that I need to multiply to get x squared are x and x. So it means my two brackets will have x and 2, and the other bracket will have x and 2, but because it's a difference of two squares, it must be plus and minus. Then this is equal to 0, becomes x is equals to negative 2, or x is equals to positive 2. Now, this one, guys, it's a bit easy to check your solution. How do you do that? Substitute the minus 2 back into the original equation. It becomes minus 2 squared minus 4, and then minus 2 squared is 4, so 4 minus 4 will definitely give us 0. Same with the positive 2. 2 squared is 4. You subtract a 4, it gives you a 0. Now, with the second example, the coefficient is also a perfect square. It becomes 9x squared minus 16. The factors of 9x squared are 3x and 3x. The factors of 16 will be 4 and 4. Remember, it must be plus and minus in the two brackets equal to 0. You solve for x here, it becomes 3x is equals to minus 4, or 3x is equals to positive 4. You leave x on its own, it becomes, let me just write my equal sign correctly there. It therefore becomes x is equals to minus 4 over 3, or x is equals to a positive 4 over 3, right? So it's like a plus or minus 3. Another example here, this is definitely not a perfect square minus a perfect square. You can already see that. Why? Because 2 is not a perfect square, 8 is not a perfect square. There are no two numbers that if I multiply them, I will get the initial equation. But I can then take out a common factor here, which is 2, which will then give me x squared minus 4, you see? And then this becomes equal to 0. Now, in the bracket, I now have a perfect square minus a perfect square, which will then qualify it as a difference of two squares. Remember I said with a common factor, when you're dealing with equations, you can divide both sides by it, right, to get rid of it. Then it becomes x squared minus 4. 0 divided by 2 is just 0. And then you factorize this, becomes x and 2, x and 2, and then a plus and a minus equal to 0. Then it's x is equals to minus 2, or x is equals to positive 2. Another example here will be, firstly, remember the main step that I said we always need to adhere to is that it is in standard form, meaning one side is always equal to 0. So, firstly, you must make it in that form. It becomes x squared minus 36 equal to 0, right? And then x squared is a perfect square, 36 is a perfect square. So I can then factorize this using the laws of a perfect square. It becomes x plus 6, x minus 6, and then it's x is equals to negative 6, or x is equals to a positive 6, and those will be my two solutions. Now, with this one here, you can automatically see that this is definitely not a perfect square, as I told you, right? They are two perfect squares, but they are not subtracted. So it's not a difference of two squares. So you can't then open two brackets and want to factorize this. Instead, your solution here will just be no solution. That's all that you are just going to say here. You'll say no solution. Why? Because this is not factorizable. And also, if you go back to the concept of taking out square roots, remember, if it was x squared is equals to minus 1, I can take out square roots both sides. If I take out a square root here and a square root there, it will be x is equals to a non-real number, because Square root of a negative number is not defined under mathematics, right, in this curriculum that we are actually doing. Now, with all the previous examples that I've done, guys, you will see that one common thing is I always start with a plus in the first bracket. Why is that? I hope you were thinking about that, right? The reason for that is because when you're writing your solutions in maths, you must always start with the least value, so the minimum value and then the maximum value. Remember, ascending order. So always try to start with the smallest one and end with the biggest one at all times. Guys, let's just take a quick ad break. When we come back, I'm then gonna do another range of examples now to bring all of what we've done so far into perspective. Please stay tuned. I'll be back just now. Hi guys, welcome back from the ad break. So as I promised you, we're now going to do a range of questions, but with these questions now, I'm going to solve for a variable a instead of the variable x, right? But it's really the same concept as solving for x. I'm just gonna substitute x as a in this one, and then we'll be solving these questions. But for now, let's just have a look at them. Remember, my main step, my very first step one, is to make sure it is in standard form. Standard form means everything on one side and one side equal to 0 at all times. Then you can simplify or you can factorize and then solve. But if that's not the case, you must make sure you take it to that before you can solve. So let's have a look at these questions. Now, the very first question is solve for a, as I said. It's 9a squared minus 25 equal to 0, right? So remember, this is going to be 3a plus 5, 3a minus 5 equal to 0. And then it becomes 3a plus 5, just so that we can refresh memory how we equate them, equal to 0, or 3a minus 5 equal to 0. Then you can make a the subject of the formula. So it becomes 3a equal to negative 5. A is equals to minus 5 over 3. Or 3a is equals to 5, and then a is equals to a positive 5 over 3. Remember the interesting fact that I just said before we went to the ad break? The minimum number must always be the first one, followed by the maximum number at all times, because that's really the rule of mathematics, right? You start with the smallest one and you end with the biggest one. Now with this one, it is in standard form. Number one, is there a common factor? Definitely. That's where we start. So my common factor here, 2 is divisible in all of them, but that's not the highest common factor. 4 is also divisible in all of them. So I will divide everything by 4, right? If I divide everything by 4, I will have a squared plus 3a plus 2 equal to 0. The last term is a plus, so it means my 2 brackets will be plus and plus. Why? Because the middle term also is a plus. Then I will have a there. A, my factors of 2 are 2 and 1. And this will be equal to 0. Then I will have a is equals to minus 2, or a is equals to negative 1, right? So let's quickly test for this one, right? Because we have not really been checking our answers, so that we remember that we need to check them. To check my solution here, I need to substitute the first one, minus 2. So if it becomes 4 into minus 2 squared plus 12 into minus 2 plus 8. This must give me 0 for 2 to be part of the solution. And then 2 squared is 4 by 4. That becomes 16 minus 24 plus 8. 16 minus 24 will be minus 8 plus 8. It is definitely equal to 0. So this is correct automatically, really. With the negative one, it will also be correct. So minus 1 squared, it will give me 4. 12 multiplied by minus 1, it will be minus 12, then plus the 8. 4 minus 12 is negative 8, plus 8 it will be equal to 0. So both my solutions are very much correct. Remember, I said one of the main things that you always need to make sure you look forward to is to make the first term to always have a positive coefficient, right? So here my common factor is not just going to be the negative. It will also be the 3 itself, right? So we'll see whether the 3 is divisible in 27. Yes, it goes in there 9 times. Is it divisible in 54? Yes, it goes in there 6 times. So this will be a squared minus 9a and then plus 6, not 6, 18 times I mean. Let me just erase this. 18, right? So this will be 18 equal to 0, right? And then you can then simplify this. If you simplify this, you'll find that it will be a into that bracket, which will be another a on the other bracket. Then I need the factors of 18, that will give me 9. It will be 6 and 3. And then because the last term is a plus, it must be plus and plus or minus and minus. Remember what tells us which one to choose is the middle term. It becomes minus and minus equal to 0. Then a will be equal to 6, or a will be equals to positive 3. And that will be my 2 solutions. Even here, if you were to substitute them back there, I promise you it will give you the correct, the left-hand side equal to the right-hand side. Now, I just want to go back to show you guys how did my signs change, right? So this minus, it came about because I divided the 27a by negative 3, right? So negative and positive will give me negative, and then 27 divided by 3 is 9. Even with the 54, it was minus 54 divided by negative 3. So negative and negative gave me a positive. Then you divide those two, then it will definitely give you the 18. Another question, remember, it must be in standard form. If this was a plus 4 and 5a minus 4 equal to 0, then I would go straight into my factor law rule, right? But it is not equal to 0, which is what the standard form is supposed to be. So I must first make it to be in standard form where one side is definitely equal to 0. So this will then be 5a squared minus 4a plus 20a minus 16 plus the 16 equal to 0, right? Because I want this to be equal to 0, but I can't just take it on the other side and not FOIL out my 2 brackets, which then gives me 5a squared. These ones will give me plus 16a minus 16 plus 16 will then give me 0, and this will therefore equal to 0. And then from here, I can take out a common factor. My common factor will be a. It gives me 5a plus 16 equal to 0. I cannot take out a number as a common factor because 16 and 5 do not have anything in common. One is an even number, one is an odd number. And this will therefore be a is equal to 0, or 5a equal to minus 16, which will eventually be a is equals to negative 16 over 5, and that will be the final answer. And then you can always check your solutions. Please don't then try to say a plus 4 equal to minus 16 as one solution, and then say or 5a minus 4 equal to negative 16. This is very incorrect. Please don't even try it. Only when it is equal to 0 can you then use that rule that we've been talking about. Even with this one, you definitely need to make sure the 8 goes to the other side. So it becomes 2a squared plus 5a plus 10a plus 25 minus 8 equal to 0, right? And then you simplify this, it becomes 2a squared. The 5a and the 10a will definitely give me plus 15a. And then the 25 minus 8 there will give me plus 17 equal to 0. And then you can already see that this I cannot factorize. Oh, yeah, I can definitely factorize this. So it's 2a, and I will need to have 17 as well, and then I will have a and 1 there equal to 0. The bigger factor must get a plus, so it will be plus there, and it will be minus here. But now, this cannot be, right? I do have the correct factors, because 17 minus 2 is definitely 15. But now this is a plus, so you can't multiply these two, you see? So I was correct. Then you'll say no solution, right? No solution for this. We can definitely not factorize that. Now remember, guys, you need to recall that if a multiplied by b is equal to 0, then a is definitely equal to 0, or b is equal to 0. That's the rule that we've been talking about, but only if it is equal to 0. So my previous two examples, it was not equal to 0. This is a and that is b, but it's not equal to 0. So you must first make sure it is equal to 0 before you can apply the law. Similarly, with my previous example, it was equal to negative 16, meaning it does not abide by the law that I'm just giving you now. So make sure first that it is equal to 0 at all times. And then solve the quadratic equation by different methods of factorizing. You can factorize by a common factor, by the binomials, or by just the difference of two squares. Always check your solutions so that you are sure that you have done the correct thing as you are solving. Guys, quadratic equations are really not that difficult, as long as you make sure that one, it is always in standard form where one side is 0 and then everything else is on one side. Look for the common factor if you can find it. If not, just factorize and then go straight to your answer. Also, test your answers at all times so that you know that you have got your answers correctly. Guys, from me, the Maths Doctor, remember, mathematics is food for the soul. Until next time.